All right. So 5G? Oh yeah, 5G. Okay. Real quick, recall. What would you do with that? Yeah, distribute the power, right? Because what are powers based on? What operation are powers based on? Multiplication. So they will, all day long, they play really well with multiplication. So the 4 power can go on the 2, the square, so that would be 2 to the 4th, x to the 8th, y to the 12th. Because this is the situation where you multiply powers, right? 4 groups of 3 y's is 12 y's. That's the definition of multiplication, right? And then this would be 16, blah, blah, blah. So, again, the process does not care that that's not a pretty number. The process doesn't care. We care, because we're the humans. But how do you do it? Well, you put the negative 2/3 on the 8, so it'll be 8 to the negative 2/3. What do you do with the powers? Multiply them. So what do you get?
Minus 4.
Negative 4/15. And then here you would get what? And again, if you want to, you can just write what you got to do and then do it on the next step. So you know you got to do that times that. Now on the next step you can actually do it, right? You don't have to do it all at once. Yeah, you got it.
Why the second?
Yeah, because the negatives cancel, the 3's cancel. Right? So that part is y squared. What can I do with x to the negative 4/15? The only thing I can really do with it is what? I know it's a weird question. Yeah, exactly. Right? So I can put that underneath. What about 8 to the negative 2/3?
Maybe the 3rd root.
Yeah, but first I want to do what? Probably something related to what we just
I'll put
did.
it on the bottom.
Yeah, so it wants to flip, and then I can do like you're saying. So I got everything done except for the 8 piece. Alright, so let's take a step back. Let's see what we did. No matter what that looks like, it's got to distribute to all the pieces. So I gave it to the 8 to the negative 2/3. Now some people would say, well, why did you do that, and why do you multiply these? Well, what power's on the 8? 1. What's 1 times that? That. So I mean, you still multiply the powers. There's a 1 on the 8, multiplied by the negative 2/3 is negative 2/3. And then you multiply that power by that power, bam, and you multiply that power by that power, bam. Any negative powers you flip, because that's what a negative power means. And I can still do the 8 to the 2/3 like you said. The 3 tells me it's a
3rd
root of 8 to the
squared.
2nd power. Like cube root of 8 is squared is 4. Coolness. Yeah.
5 echo.
Let's see. I like the way you asked that. I felt all cool for a second. Roger that. Let's see. Okay, so this guy, this is the one that we really, really don't like. All right, can somebody tell me, and this is the big problem that students have with math in general, why do roots treat numbers differently than they treat powers? It's a weird question to ask, I know, but I want you to know, because part of your brain kind of rebels against that, and sometimes people just say it directly. Why did you do one thing to this and another thing? No, well, that's because 320 is not written as a factored thing. Whereas these are all written as factored things. There's 6 A's, 14 B's, but I don't have this factored yet. So there's 2 ways to handle this big, bad, ugly thing. You can either prime factor it, right? A few of us like that method. I prefer the method, now here's the interesting thing, you got to know some 5th power stuff. Right? 1 to the 5th power is 1. That didn't help me worth shit. Thanks, 1. Well, what's 2 to the 5th power? 32, right? And if you don't know what it is, it's 2 times 2 times 2 times 2 times 2 is 32. And why is that cool? Because 320 is 32 times 10. Kick ass. That's my personal preference. I like to break it up into a number I can do and times whatever. But if you prefer to just break it all the way down and then circle, 5 2s, that would work also. Nothing wrong with that. That still works. It just takes a little bit longer. So I can break 320 up into 32 times 10. Now let me explain these a little bit different. Well, first off, what is the 5th root of 32 then?
2.
It's got to be 2, because the 5th root says, what does it take 5 of to make 32? So 2. What's the 5th root of 10? Oh, a freaking clue. All right, so it stays inside. I don't know what to do with you, so I'm just going to leave you in there. Right? All right. Now, based off of what we just did, let me overanalyze this guy. Let me do it the long way, and then I'll remind you about the shortcut. Let me just focus now. We're in the middle of this problem. I want to point that out. I'm going to pull just this piece over here for a second. Just to look at it. And then I can do like I did here. Why did I break this up as 32 times 10? Because the 5th root can attack 32. So 8 to the 6 sucks. What would be better to have? There's a power for the 5th root. A 5th power. But 8 to the 6 has 5 A's in it, right? It's 8 to the 5th times A. And what's the 5th root of 8 to the 5th? Those 5's cancel, right? And then the 5th root of A, I don't know. So just like the 32 had a piece come out and it had a piece stay in, the 10 had to stay in, you can look at that the same way. But that explains why the shortcut works. If you want to write this so you can see it, that's cool. But the shortcut works because 5 goes into 6 once. You can write one group of 5 A's. 5 goes into 6 once. That relates to this one group of 5 A's. With 1 left. It kicks ass. With 1 left inside. So the way you've said it ever since you learned division has readied you for this moment. Right? This is it. This is your pinnacle. And then it's all downhill from there. So how can I do this one? For the B's. 5 goes into 14 twice. And that makes sense because there's 2 groups of 5 B's, right? There would be 10 B's. That's 2 groups of 5 B's. And then, the other 4 are left in there. I like it. With 4 remainder. Now, does 5 go to 4? No. So no C's come out. So just put a times dot there. Just take up space. And so all 4 C's, too bad for you, you stay inside. Freaky shit. So the number you break up somehow, you factor somehow. Either you prime factor it, or you factor it just using the right number. Like something that goes with that root. And then the letters, it's a beautiful shortcut. Believe it or not. All right. Yes, sir.
5I.
Oh yeah, it looks gross. What do you do with the powers when you divide like bases? Subtract. Cool. I like it. And that property can never change, right? The whatever's inside the problem does not change my property. So in this problem, I've got x to the 4/9 divided by, this is 5i, x to the 5/12. So what am I actually doing? What am I going to do?
Subtract.
Yes, but now real quick, this is a mistake. And even if you get the right answer at the end, this is still bad. Don't write this. You're not doing this, right? Don't tell me that division becomes subtraction. But be careful. So I understand that you write it, and I know that you kind of know what you're doing, but you're writing something that's not correct. So what you want to do is you want to say the like base is x. And what do you do with the powers? Subtract. I know it seems like a small thing, but the more you do that, the more it reinforces the wrong thing in your brain. You keep seeing the wrong thing, and it's going to reinforce that. Plus, your teachers are going to go a little crazy. More than me, maybe, with that. If you have to do any more math anytime in the future. You never know. It seems to pop up. And then, of course, for this problem, I have to get LCD. What would the LCD be?
36.
36, I love it. So it'll be x to the 16. 36 minus 15, 36, which is x to the 136. Kick ass.
That's it?
Yeah, dude. That's awesome. So the where people put themselves in a corner, right? Don't put yourself in a corner. Don't put baby in a corner either. Is when you rewrite this in root form. Thank you for that. I was hoping somebody could get that. Don't write this in root form. That just doesn't go with the property. The property is all about division, tells you what to do with powers. When you write in root form, they're not going to be the same root. It's all going to be disgusting. Right, so don't do that to yourself. Yeah.
Is section 12.7 and 12.8?
No. So I think I said that last time. We only made it up to 12.6. And I only have up to 12.6 on the practice test. So 12.7, 12.8 on the next test. So you don't have to do the homework yet. I shouldn't have posted those online yet either. Yeah.
Can you do 7 big, please?
Yeah, since you asked so nice. Which in general, so let me talk about this in general. You just write a bunch of crap up there. Which one of these would have a problem with their domain? Which one of these couldn't use all real numbers? The answer might be all of them, by the way. Maybe I'm being really tricky.
I'm thinking...
Which one of these would have a problem? Even roots have a problem. Most of us, if I ask you guys, what's the cube root of negative 27? You've seen this before. You've seen that. You know what that is. What is the cube root of negative 27? Negative 3. Because 3 negative 3s makes negative 27. There's a third negative that's still there. The other two kill each other. Which is exactly why this guy is not doable. 2 negative 3s would multiply to make positive. Like shit. So any even root would come from an even number of things that could never multiply to be negative. If you have an even number of negatives, all the negatives die. With me? Whereas if I have an odd number of negatives,
Those would be one more.
you be careful. Those two, there you go. And they have one negative left over. So that's why odd roots can handle negatives left over. Even roots can't. So these two would have what kind of domains? What would their domains be? Do they have any problems? If they don't have any problem, they can use what kind of numbers? All real numbers. These two you'd have to do work for. Even roots you have to actually do something to figure out what x's would work. So with that in mind, 7b has what kind of root? Odd root. So what kicks ass about that? All real numbers. And just to make this clear, I'm not going to do this, because in a way it would be slightly evil, but I have to tell you this. If I gave you, and I think I told you this before already, if I gave you that problem, you don't say it's an odd root, so the domain is all real numbers. The odd root doesn't have a problem, but what has a problem? Why is there a problem somewhere? What part of that has a restriction? What can't happen? Beautiful. So x can't be 1. So you don't say the odd root makes everything good. No, the odd root doesn't contribute problems. It has a problem on the inside. This guy, the inside, is just a freaking polynomial. It's just a 3x plus 12. And I can plug whatever, I can triple any number I want to and add 12 to it. So the odd root has no problems, the inside has no problems, all real numbers. Cool?
That was the answer for that one.
Yeah, dude.
So what would be the bottom one? Because that looks.
Oh yeah, so x can't be 1. Done.
That's it.
You don't have to worry about this because he has no problems.
What if that was 4? The square root of 4.
Well, the fourth root? That gets interesting.
Yeah. The ones.
You ready?
Yeah.
This could be a bonus question.
Oh, wow, okay.
Because x, this, 1 over x minus 1, well, this would be a super bonus problem, I think. That has to be positive, right? 1 is positive, so the only way this could stay positive is if x minus 1 is positive. So x minus 1 has to be greater than or equal to 0. It can't be equal to 0, right? So as long as that denominator is greater than 0, it'll work. So x has to be greater than 1. Okay, that was weird, right? Because you had multiple issues kind of going at each other. So that's a little beyond. I might do a bonus problem with that. The problems you're going to have to deal with, they'll have one issue at a time. That's enough. As far as domain goes. Yeah?
Sorry, I came in kind of late, but for at the top one, the polynomial,
Yeah?
just the answer would just be all real numbers, right?
Yep. Because the root, there's no problem with the odd roots, and the inside, there's no problem.
Yeah.
Okay. Yes?
You can find out on practice test.
Okay. The problem, the way people make this harder than I intended is to try to rationalize that. Gross. So, and I understand why people would do that, because there's a radical on the bottom, so part of me goes, oh, good.
All right.
I'm just waiting for the day somebody takes their phone out. Yeah, I'm in class right now. Yeah, he's still not making any sense. Yeah, okay, I'll be there. Bye. I gotta go, Mr. Wall. All right, get the hell out of here. So you don't start saying there's 1, 2, so it needs another 2. You only do that if there's nothing else you can do, to be honest, because that's kind of a weird thing to do, is rationalizing. What's nice about this problem? What's nice about the other part of this problem?
2 goes into 98.
Yeah, both of them are what kind of roots?
Yeah.
Square roots. That's important, right? They have to be the same root. If they're the same root, I can multiply or divide this stuff inside. That kicks so much ass. What's 9/8 divided by 2? 49. What's 3 D's divided by a D?
D squared.
Good, there's 2 D's left. How many E's are left?
2.
2 E's? That's crazy.
Well, that's it.
Well, what's the square root of that?
7D.
7D. And you can do that, but I'm probably going to say, things are made out of positive numbers, so I don't have to worry about the absolute values. I think I put absolute values on the answer key. Remember that? Because D and E could be negative. But a lot of your homework says assume that the radicand was made out of non-negative numbers, right? Does that sound familiar? Hopefully it does. If it doesn't, do some freaking homework, and then it will sound familiar. All right? Okay. Yeah.
8, Charlie.
8. Oh, yeah, good. All right, good. So that's the weirdest one on here. So let's kind of build up to that a little bit. Let's remember how to handle 8 Bravo. Let's look at that first. Because that's the easiest problem in number 8, is this one. work our way up to 8, Charlie. What's your first move here?
Oh, subtract 4.
Yeah, remember this? You're the tyrant of this country, right? Somewhere out there on your own. You got a radical element that want to overthrow you. Well, that's bullshit. Right? So you isolate the radical element, and you drop whatever you got on, whatever kind of weapons. Or not. You make a whole different thing. So I got to isolate the radical first, so subtract 4. And the reason is, if I try to square both sides now, I'd have to FOIL that out, which would, 1, so be ugly, and 2, my radicals wouldn't even die. They'd still be there in the middle term. Holy shit. Don't do that. Don't do that. So get the 4 out of the way. Because now, when I do what to both sides, I kind of gave it away a second ago, but
Square.
square. When I square, the square directly kills the square root, and that's all it does. Now, one big mistake I see is somehow people, on the next step, they have this. What's wrong?
Square.
They did square, but they squared it like twice. That square should die with the radical. How is there still a square there? Right? Don't make this harder than what it's supposed to be. When you square the square root, they kill each other. That's why you squared. And so you're only left with the inside. And now that is nice. Right?
That's nice.
Yes. Let it be nice. Sometimes students don't realize how easy it is now because your brain is still thinking about this weird shit. But cover that. You're there. That's easy. What do you do? Subtract 2.
Negative 5 x equals negative 1. X
Equals
equals
4.
over 5.
Yeah.
Divide negative 5. X is 1/5. Since it's a radical equation, good Lord, I'm tired. Since this is a radical equation, what do I have to do? Any radical equation, once you get the answer or answers, you got to check it. So if you check it, square root of 2 minus 5 times 1/5 plus 4. What's that? What's 5 times 1/5?
1.
1. So what's the square root of 2 minus 1?
1.
Square root of, yeah, good. It's 1. 1 plus 4 is 5. Check. Yay. Yes, ma'am.
Do I need to show the check in the test?
What do you think?
Yes.
All right.
Because sometimes we can just check in mind. Do I need to?
Yeah, but then it's really hard for me to check your work.
Okay.
Yeah.
Wait, you
The day that I can print out a scan of your brain, that'd be awesome. Think about it. All right. Yes, sir. You can't do that.
on the test, you're gonna have to do that checking part that you have to check.
What do you think? How many
I
times?
literally just missed what her question was.
We're in a
But
loop.
okay, yeah, assume that.
Oh yeah.
It's obviously.
Something else about this. When you get to the answer, you should check it. All right. So what now? We finally can get to the actual question, which is 8C. So now we got the basic idea.
We should just do 8A after that too.
Okay. Let's do 8A first here, because 8A is the easier one.
Subtract 3.
Beautiful, right? So again, it doesn't really matter what's in there. You want to isolate your radical. That's why 8C is going to be weird, because there's two radicals. Shit. So, but here's just one radical. I want to get it by itself. I want to kill the 3. And then
Square root is
square it. Cool.
Yes.
I like it. I don't know. Recently, for some reason, that X has just kind of disappeared. Which, I don't know. I mean, you have to know that it's not going to be right. So then what's the point of doing the work? I don't understand why the X... I mean, it's happened a lot. I taught intersection, and a lot of people did that. I'm like, why? Did you just forget it? Or are you just hopeful that it's okay? And that would make it a lot easier, wouldn't it? But it would make it wrong. So yeah, you square both sides, which means what do I have to do on this side? FOIL. The next big mistake I get is people say that the answer is x squared plus 4. And then you don't have any chance. Okay? So I'll do this side.
minus 4x plus 4.
And if you need to, you can write that twice again, right? That's what squared means. Now, what part of this tells me what to do next? What's that? If part of this wasn't there, I'd do it an easier way.
What is, isn't that factorable? X minus 2 is plus 2? Or x minus 2, x minus 2? On that one, is that right?
Yeah, but that's where it came from.
Oh, never mind. Then I'm sure.
Because, like somebody just said, you wouldn't even want to try to factor this unless the other side was.
0.
And of course, it's that piece, right?
Yeah, never mind.
If that piece wasn't there, I would just add 4x, add 2, divide by whatever the hell, right? I just get x by itself. Because there's an x piece that's not like terms with the other x pieces, we had to come up with a new way to do it, which was make one side 0 and then factor the other side, right?
Okay.
That's going to happen. It's going to happen. So then you would
Subtract 3x.
subtract 3x and
Add 2.
add 2. So on this side I get 0. I love when that side just sort of stops existing. Right, that's weird. Throw this side in a black hole. So x squared
Minus 7.
minus 7x
Plus 6.
plus 6. And then you factor that bad boy.
32? Wait, no.
Minus 6 minus 9.
Yeah, it's funny. Whenever that number is 1 off from that number, the answer is that and 1. That's how it gets there. Right? So it'll be x minus 6. They both have to be minus to make negative 7. So you get x is... Alright. Yay, we're done. Yay.
No, just check.
Oh, okay. Good. I kind of was hoping you'd pick up on that.
Yeah, dude.
Yeah, so now you just plug 6 in. Take a second and do that. You got to be careful because you got to start with the original equation. You have to plug a 6 wherever there's an x. And you want to make sure that the equation's true. While you're doing that, I'm going to go ahead and give you guys the answer key. What's up? Oh.
So the first one, check.
Oh, what do you got? Oh! Say it. Best of some.
Sorry.
She was just checking all of them. Alright, so when you go to check these, let's see what this looks like. So check. X is 6. This would be square root of 3 times 6 minus 2 plus 3 is supposed to be 6 plus 1, right? So I plug a 6 wherever there's an x.
So square root of 16 is...
Yeah, 18 minus 2 is 16. Square root of 16 is 4. 4 plus 3 is 7. Check!
Yes.
So when you go to check x equal to 1, you get square root of 3 times 1 minus 2 equals, plus 3 equals 1 plus 1. 3 times 1 minus 2 is, square root of 1 is 1. 1 plus 3, is that equal to 2?
No.
No. Throw 1 out. Cool.
Sweet.
Cool. Not too bad, right? Alright. Now, finally, the ultimate level. the final form of this. How many radicals were in the equations we just did? Each one.
1,
There's just one radical. How many times do we square?
1,
Makes sense. So the last equation on there, 8c, has got how many radicals in it?
2.
2.
So how many times we're going to have to square?
Twice.
Makes sense, right? But we still try to do what we always try to do, which is to somehow isolate the radical. And do you see why the radicals aren't isolated? Because they're together. So they can work together to overthrow me. So I still want to isolate one of the radicals. So the easiest thing to do is to get him alone and to do what with him?
Add them to the...
Add them over, right? Get one of the radicals isolated. Right? If you got two radical elements, you can ask our government right now. Two radical elements working together, shit, that makes it a little bit hard. You want to isolate them. So add over. So we get root 3x plus 1 equals 2 plus root x minus 1. Now here's where you guys are going to just love it. The FOIL process does not care what's inside. It just does the same thing all the time. And the reason I'm saying that is because, of course, now we have to square both sides. Now, people get overly optimistic and they do this, and then that's easy. That's 4. But you can't distribute a square across addition because squaring is based on multiplication. Shit. So I have to square both sides, which means I have to FOIL this thing. I'll do this side. Sorry. On this side, you probably definitely want to write it out twice, just so you can see what's really going on. Right, so I just wrote that out twice, and then you FOIL it, and this is where people sort of give up sometimes. But just try it. You know how to FOIL stuff. So what do you get?
4.
Good. 4 plus
2x.
2 of these plus 2 more of these. And what's square root of something times the square root of something? That thing. So the square root of 7 times the square root of 7 is 7. Square root of 9 times square root of 9 is 9. Square root of pi times the square root of pi is pi. See, the square roots fill each other in. They're half makes a whole. So the square root of that thing times the square root of that thing is that thing. Because you would get the square root of that thing squared, and the square root of the squared would cancel. That's another way to look at it if you want to, right? It's a very good thing to know. So if you prefer, let me write it like that first. Because I still have people looking at me like I'm crazy. Isn't that what you get when you multiply that by itself? You get that thing squared?
Yes.
And what do the square and the square root do?
Cancel.
Cancel. So you get x minus 1. So you get 3x plus 1 equals 4 minus 1 is 3 plus x plus, what do I have here? 4 of these. Alright. So now what do you think you do?
Subtract 3.
Yeah, what are you doing? You're trying to isolate the radical. Again, right? You isolated one radical and killed it. Now you're going to go look at the other radical and go, if I could just get you alone, I could kill you, right? Very violent, but our history is that way. In fact, our daily life is that way. You just don't know it because you live here. That's true. So, I want to isolate my radical. So I'm minus 3 minus x, maybe line them up with the right like terms. So I get
2x minus 2.
2x minus 2 equals 4. Let me let you absorb that for a second. Of course, you got the answer key too, so I do the same thing. Here's where I want to explain what I did. Thankfully, you actually don't have to divide by 4. In fact, right now, you can just go ahead and square both sides. But what goes into both sides evenly?
2.
Do you guys see that? 2 will go into both of these, and 2 will go into that one. You don't have to create fractions, is what I'm trying to say. You don't have to. Just whatever you leave behind, when you square it, has to be squared. Right? So I'm going to divide not by 4, I'm going to divide by 2. So I get x minus, let me put it up here. x minus 1 equals 2 radical x minus 1. Which is a really neat looking equation, actually, think about it. A number equals twice its own square root. That's what that says. Do you see that? A number is twice its own square root. So we're going to figure out what that number is. It's kind of neat. Maybe it's just me. I don't know. All right. So now what am I going to do? Good. So on this side, you'll get 2 squared is 4. Square root of x minus 1 squared. Yeah, so you get that in there, right? So whatever you leave behind has to also be squared because it's on that side. And on this side, of course, what am I going to do? Foil it again. Holy shit, does this problem ever end? Right? I'm sure this is what you guys are thinking. We're almost there. So I get x squared minus 2x plus 1 equals coolness. And of course, what do I do? Get one side equal to 0, right? I love that. That's the reaction I wanted. I know it's in your head, This is one problem. So minus 4x plus 4, right? Minus 4x plus 4. So I get 0 over there. And here I get x squared minus 6x plus 5. Cool. And again, we see they're offset by 1. And the only way to factor 5 is freaking 5 and 1 anyway, so you can't go wrong. So I get x minus 5, x minus 1.
Don't forget to check.
Thank you. Now here's the nifty thing. I mean, I specifically created this problem. It's really weird to try to get both answers to work. So if you check both answers, they'll both work. It's kind of neat. So the number 5, what would it really be? What's x minus 1 if x is 5? If x is 5, what's x minus 1? 4. So 4 is twice its own square root, which makes sense, because the square root of 4 is 2, and twice 2 is 4. Right? If x is 1, what's x minus 1? 0. So that one's almost kind of silly. 0 is twice its own square root because the square root is 0 and 0 equals 0. Did you have to know at all or look at it in the way I just said? No, you never did. Never ever did in your whole life. But there you go. So you still have to check it, and if you check it, the check's on the answer key. They'll both work. It's kind of nifty.
Good question. In 2 seconds.
What's up? Oh,
I'll look for it real quick.
Okay. I love so many looks in your faces.
This is going to be the hardest question.
Huh? It should be, yeah. It's just the longest question,
That's
really.
pretty much what it is.
Yeah.
Yeah, how did that 4 become a 3 also? I don't know how I missed that, but you see it says 4 plus 2x.
Oh,
plus
there's a
2
little
square
piece
root
here
x.
that kind of died. Remember, this square was x minus 1. So what's 4 minus 1?
Oh!
Yeah. So I'm just combining like terms, and these two went there. 4 and 1 went together, and then I just put the x over here so I can see it.
I
Better.
see.
Yeah.
Yes.
So it's just a cleanup step to get your like terms together.
I see. Okay. What happened to the x though? Oh, it's there too, right?
Yeah, it's still there. And then just take it over to that side. I like it. Yes?
Can we try 6 weeklies?
I don't know. Let's see. So, well, I'm about to say something like, no matter how much I say this, I'm still going to get somebody that does the most common mistake, because it's the most common mistake, which is somebody just brute forces, adds 40 to 135, and takes 5 away from it, and just gives me that's the answer. Right? And who do you think that will be? That will be the people that aren't currently here and have not been here for a week and only show up when there's a test. right? And those people, I love those people. I really do. Right? I do. No, not at all.
Keep looking at your videos on YouTube.
Yeah.
It's the same.
Yeah, they're the people that think that they can make this into an online course, and that, of course, is complete bullshit. Has anybody ever taken an online course? Are they easy?
Depends on the instructor.
Alright.
Some are
They're-
geared differently.
Yeah, they're not easy. I never want to teach online. They teach 103 online. I don't know how the hell they do it. It would be impossible. No. Anyway, so what's the correct way to do this? Because are these like terms?
Yes. No, excuse me, no, they're not. I was looking
You have to
I'm sorry.
Yeah, like
pull them out.
automatic pilot or something. It's urgent. Yes. So there's no other root cubits of 40 or anything, right? It's like there's no like terms currently, so but I can force them to be that way, right?
Yeah.
What can I do with cubit of 40? What can I do with 40? Good, I can break that up as cubit of 8, cubit of 5, and that's a smart way to do it because 8 is cube rootable, right? Is to make a new adjective.
So as long as you have one that's, you break three, you're okay.
Exactly. Good. That's the way you want to break it down. Yes. And then, of course, 135, if you're not sure, you know that 5 looks to be the common piece. So you divide 135 by 5 and you find 27, which is cube rootable. So that is here. This is here. And this little dude is just sitting out there waiting. Right? There's ain't nothing he can do. So what's cube root of 8? 2. So you got 2 cube roots of 5. What's the cube root of 27?
3.
So let me make this really explicit. This is
Why do you pull out that two?
this one.
Yeah.
It's here.
Oh.
That's all. It's just already there. Yeah. And then it's what's the 2 doing to this thing? Multiplying. So whatever I do manage to get out, it's going to multiply by it. So if there's a number already out front, it's just going to multiply by whatever piece you can pull over there. Because it's all multiplication. So I get 2 cube root of 5 minus 6 cube roots of 5 minus another cube root of 5 leaves me with 2 minus 6 minus 1.
No, you did some
The first one
minus
is
plus.
Plus. I just want everything to go away. So 2 plus 6 minus 1, 7 cube roots of 5. I like it. Cool.
Wait, 2 plus 6
Yep.
minus 1.
Yep. Good.
They all have the same base.
I'm hoping I did that. Yeah. All right. I did it right on the key. Yeah. Let's sing it. Yeah. They all have the same. So that's what makes them like terms. This part is what makes them like terms. That's the part that acts like x. Because what is cube root of 5? And what do we do when we don't know something in algebra? We make it x, right?
Yeah.
We don't know something. So I could write this as 2x's plus 6x's minus another x. 2 somethings I don't know plus 6 of that same damn thing I still don't know minus the freaking thing I don't know is 7 things I don't know. That's why they act that way. That's why the idea of like terms still applies. Because it is something I don't know. They act just like an x, which is something I don't know.
It's so easy.
Okay, it's my favorite phrase. I just wish that it was more widely accepted. Got to be careful when you say it. You got people that are like, "Shut up," which I understand. I mean, this is not like obvious. Our human brain is not wired for this stuff immediately. That's why it's difficult. Yeah.
Can we try 4D? That's okay? I just want to,
I don't know.
it looks simple, but I just want to.
So real quick, I think I only had like one person do this, but just to make sure that that streak continues. What's the square root of 9 plus 4?
22.
See, that's the problem. It's not that. Square root of 9 plus 4 is the square root of 13.
Oh. So
It
it's
cannot be 3
question.
plus 2. You can't tell me that square root of 13 equals 5, right?
It's a trick
That's
question.
no good. Not a trick question. It's because a root is a power, and a power can't go across addition, right? So when you see this, I always have at least one person, I forgot what the hell it was on theirs. At least one person tell me the answer is x plus radical 12x plus 6. Do you see where that came from? Square root of x squared is x, square root of 36 is 6, and then I went out and looked up.
Wait, what does it say? X is. Oh,
They just took the square root of each piece, but that's like taking the square root of each piece of that. It doesn't make any sense. You can't distribute a power across addition. Or else FOIL wouldn't exist, which we wish it didn't, but then nothing would work. All our equations would be shit, right? Okay, so that's bad. So what you want to do is what we do with a number. What do we do with a number when we don't know how to do the root? We factor it. Because what is this thing? It's a number I don't know. So I really don't know how this word is going to work because I don't even know what the hell this number is. So how do you factor it? Here. 6 times another x plus 6, so x plus 6 squared. And that's what makes this doable. What's the square root of x plus 6 squared? X plus 6. Yeah, I can't remember if I put in absolute values. Again, on the test, I'll probably say none of the radicans are negative. None of the stuff on the inside is negative. So you don't have to worry about absolute values, right? Again, if you've been doing your homework, you should be used to that by now. Did I go off about homework last time?
That's it?
Did I? Oh, real quick, let's do this before I go off about homework. Give me a number for x.
8.
8. Okay. So if x is 8, what's x squared plus 12x plus 36? Somebody help me out. Now x squared would be what?
64.
64. 12 times 8? 96 plus 36. And what's all that? Let's see.
It's a lot of numbers.
True. 4 and 96 is 100, plus 60 is 160, plus 36 is 196. Crazy. Now, what's to say it's supposed to be the answer? If x is 8, x plus 6 is 14. Is that true? Is 14 times 14 196?
Yeah.
And we saw that when we did factoring, right? I did that. I put a number in for x, and I showed you that to factor that way. It's nothing magic. It just says no matter what x is, this square root can be done like that. And, you know, it is kind of nifty, but that's the power of math, is it makes it look like a trick. But why does it look like a trick? Because when we do this, we actually just did this for an infinite number of numbers. Because what could x be? Infinite number of things. So this work is semi-difficult. More difficult than if I ask you what the square root of 49 is. It's definitely more difficult than that. But that's because it's an infinite number of numbers. So when I do a specific number, it's like magic. Right? But of course it's not. We just proved it for every damn x. Of course it's going to work for 8. So whatever you said, it was going to work. Right? Nothing special about 8. If I said, tell me the number of TVs in your house. Oh, look. You know, don't you hate those? Now take the number of TVs you have and double it. Now add 5 to it. Now subtract the year you're born, and that's 11. Holy shit. And all they're doing is using freaking algebra. They just worked it out beforehand. Ooh. Right? I don't know if you ever heard something silly like that before. Okay. Yes. So real quick, analogy. Because I am worried about you guys with homework. Students look at homework completely wrong. A lot of people try to just do it because they think it's part of the grade, and if they can get it perfect, then somehow they get great. I don't know if you guys realize this, but homework is a part of the quiz homework average. Homework comes out to be about 5% of your grade. So if you don't do it, it will hurt you. And you can see on the grade sheets, I give out that, how much it hurts you. But if you cheat on it, it's not going to help you so much to cover you. You understand? So my analogy is, if you went somewhere and Who's trying to get better at something like basketball or tuba? What are you trying to get better at?
Speaking Czech.
Oh, speaking of Czech. All right, holy shit. She's trying to learn the Czech language.
Yeah.
Okay. It was weird when he did that. That was Czech 1, 2, and then it was like, no, he means the language. Okay, speaking Czech. I'm speaking now. I'm speaking. You're doing a good job. Sorry. So if you're going to take if it was like an online Czech speaking course, right? And I said, I want you to record yourself speaking Czech, and then I can check your Czech. And give you notes to help you improve, right? You with me?
Yeah.
But what you do is you go find somebody who sounds like you,
Yeah.
and you have them, and they speak Czech perfectly. So then when I'm like in Czechoslovakia, I'm your teacher, and you've enrolled in some massive online course, and I get your recording, and I listen to it, I'm like, yeah, you're doing pretty good. So my notes are, things are going pretty well, it seems like you're doing pretty good. And then when you go to take the test, you suck. Because it wasn't you doing that. So homework to me is homework. I'm saying do something. Make mistakes. Be honest about it, because when I get your homework, I'll help you work through what the hell it is. If you give me shit, which not everybody is, but there are enough people that's really driving me insane, giving me stuff that's obviously copied from somewhere. I just look in the solutions manual and it's exactly the same setup, and I'm like, okay, this is shit. I say, stop wasting my time. Just tell me you're doing this so I don't even waste time on you, right? And then the test comes and you're like, I understand, I come to class and I do the homework. You don't do the homework, shit, right? So if you haven't done the homework, or if you are one of these people that are just, maybe you don't mean to be cheating, you just want to get it done so that you have it done. And so you kind of take it from other places if you're behind. Stop doing that shit. Just be honest. Turn it in, say, I'm sorry, it's so undone, I'll finish it when you give it back to me. But if you give it to me early enough and I can give it back to you to study for, that's the whole point. I don't get it. I don't. And it's happening more and more often. It's driving me insane. Right? And a lot of teachers are doing online homework now, and who knows who's on the other side doing that homework, But I don't know. Anyway. So I do make it an option, but just because there's some people who really like it, they get something out of it. Right? But some people really misuse it. Yeah.
The good thing about my math lab is it gives you examples, step by step.
I like the promise of it, but again, some people misuse it.
Yeah.
Right? You can game any system that's set up. I know that's true, but yeah.
Did we ever touch on the subject of extra credit?
Yeah, you can make corrections, tests, and quizzes. And there's been several sections that are extra credit. Remember those? Normally I don't do that, but I just did.
How much are those worth toward your end of the semester?
What I do is, if you turn in all the homework, that'll make your homework grade go above 100. Right? Probably by like 2 or 3 points, so you'll have like 103, 104 homework average. And that'll average it. If you miss some of your homework, that'll just fill that in a little bit, if you do the extra credit. Well, that does not make any sense to me. If you didn't do a section that you had to, but you did the extra credit instead, whatever. But still.
Time management.
That's fine. Right? If you're like, I can't make corrections on all those, I'll just do some extra credit. All right. So that's why the option's there. Yeah. All right. So where are we going now? Are we all good with the earlier stuff? Before I forget, there is one kind of problem I didn't put on here. And that's like the substitution elimination problems, right? That will still be on the test. I mean, those sections are still on the test.
You do a substitution problem? Because elimination is not easy.
So, hopefully that works. We'll see. We'll see. All right. Why is the way this is set up just screaming to be substitution? Yeah, we know what x is. X is this.
Yeah.
So when I go to rewrite the second equation, I can write it as twice x. But what's x?
4y minus 3.
Now, a lot of times people forget the minus 5y, and I think it's just because you wrote so much here that you're kind of lined up. Don't forget the poor little minus 5y, dude. Right? And then now you've only got one variable in that equation, so you can solve it. So I got, let's see if Jeff made a problem that works. 8y minus 5y is 3y, add 6. Y is kick-ass. And what's nice about substitution is you already have an equation solved for the other variable. X is 4 times y minus 3 is 4 times 3 minus 3 is, 12 minus 3 is 9. Make it 9, Jeff. There it is, Jeff. Cool. So that's acceptable, but what's kind of like the really right way to put the answer?
9, comma 3.
Beautiful. X, Y, 9, 3. Because the idea is it's where these two lines would meet if you graph them.
Quick question, can you give us one of those problems with the 3? I love the elimination, but 3 questions on it?
Maybe. Yeah. Those are take a long time. So it's hard to fit them in. But we'll see. It could be on there.
Okay.
Yeah. Might be bonus. But it could be a problem. Depends on if I can fit it in. Yeah.
On the practice test, 4C has negative in the square root of -16. I got negative 4i, but it says
You're
it's
fine.
not real, so.
Yeah. I mean, officially we don't know complex numbers yet, but if you use them correctly, I'm not going to take points on. If you've already seen complex numbers, and all of you should have, but maybe some of us, it's been a while, you don't have to. If you get the square root of a negative number, that's not real. That's correct, because the answer is imaginary. Right? But if you know about them and you want to put them down there, cool, just be sure you use them correctly, because I will take points off if you don't use them correctly. I like it. So if you've forgotten what imaginary numbers are, don't worry, we haven't talked about them yet. That's section 12.8. The unfortunately named imaginary numbers. Right. Dude, I thought of a number. Totally in my head. It doesn't exist. Yes?
We do G.
With 2.
Do you have
Which
office
one?
hours tomorrow?
5G we did.
Do you have office hours tomorrow?
Yes.
First one.
Wednesdays, 9 to 9:30, right before my 9:30 class. And then, what is it, Wednesday, what is it, right before my 3:30 class, 2:45 to 3:30?
You have office hours tomorrow? Sorry, dude, I was...
You can always reference the syllabus also. I still got to get that shirt. It's on the syllabus. I want that shirt. One of my colleagues has that shirt. Hey, what is extra credit? Stop it. Someday. Just wear all my... Show your work. It's on the syllabus. Be quiet. I got nothing. It's all dependent on what you got. If you're ready, you don't have to sit here staring at me. You're kind of creeping me out. Yeah.
Can we try 5J, please?
Oh, good. So that's the one that there's nothing you can simplify there, right? So what do you have to do on 5J? I mean, what I mean by that is it's not like 5D or anything like 5D. It's not like 5F or D.
Yeah, don't you times it by the denominator?
Not really, no. And see, that's the unfortunate misunderstanding about this. That's why forever, from now on, forever and ever, I can't remember the last time I did this, but I used to start teaching rationalization starting with square roots. And if something is a square root, how do you rationalize this? What is it missing? What does a square root need? How many things? 2 things, and currently only has 1, 2, so I multiply by rad 2. Now, if I didn't just start the discussion here. I started with a cube root. Because I wanted to show you, the idea is not multiply by whatever's there. The idea is multiply by whatever's there is missing. So if it's a square root, it's missing itself. Which is a really deep psychological problem. Right? So no matter what, if I would have a 7, you would have given it another 7, right? Ooh. But this is a 5th root. Don't say it has 1 8. What does it actually have?
3, 2.
Yeah, it's got 3 2s. So how many more 2s does it need?
2.
Because it's a 5th root. That's why I like to call it completing the root. Whatever the root wants, the root gets. The root wants 5 things, we're going to give it to it. So I got to multiply by 5th root of 2 squared, 2 more 2s. And how many more a's? Just 1 more a, because it's already got 4. Right? Whatever I do to the bottom, I better
Do to the top.
do the top. Cool. And then, of course, I mean, you can see on the answer key how it goes from there, but that's where I got that from. Just looking at, it's a 5th root, needs 5 things. How many more does it need? Bam, bam. Don't make more out of the problem than what it is. Now, if I gave you a problem like this, oh, scheisse. Good. I felt like it's so root 5 plus 2, and that's called the conjugate. Right? If you ever taken a foreign language, it's kind of like that word, conjugate your verbs.
Yeah, sir.
Je suis. Right? So you multiply by the conjugate, root 5 plus 2 over root 5 plus 2. You multiply by the conjugate, top and bottom. That's what I actually don't call it conjugate, I kind of call it the difference of squares pair. Together, don't they make a difference of squares? That minus that plus that's the difference of squares. The middle term's going to cancel, so there's no radicals left. So what's rad 5 times rad 5? 5. Minus 2 plus 2 of those, gone. So what's negative 2 plus times positive 2? Negative 4, good. So that's what I get on the bottom. I get 1, that kicks ass. On the top I get, what's rad 3 times rad 5? Rad 15. What's rad 3 times 2? 2 rad 3. Good, I didn't hear any 6s. Good. So it's plus 2 rad 3. It's not 6 because that's not a rad. It can't go inside. It doesn't have the same rad. It doesn't have the same root. So on the bottom I just get 1. That kicks ass. Bam. So, real quick, let me see if you guys get this. What is that times that? Square root of 3. That times that must be that, because that divided by that is that. Hey. And is that like part of the problem? No, but it's kind of... division doesn't give a shit what's there. If that divided by that is that, then that times that is that. I mean, that's how division works. But it's really weird when you start looking at weird-looking numbers. But it still works. You don't have to stay here if you're ready. Some of you guys are like, I just want to be here if somebody asks a question. But then we'll just all stand here and look at each other. Yeah.
We do like B or D or I'm sorry, C or D? I can't tell.
5C.
No, the one.
Oh, I don't know. I think I erased C and I forgot to change it. Yeah, so it's 1D?
1D.
Okay. Yeah, 1C was there and it's gone now. So 1D... Now here's the interesting thing about this problem. If that wasn't there, this is an interesting problem. What is the absolute value greater than a negative number? What is the absolute value not bigger than a negative number? Absolute value is always at least
It's 0.
0, right? It's always positive. So if that wasn't there, the answer would be all real numbers. Well, if it was less than, it would be no solution. Because nothing can make an absolute value less than a negative. But every freaking absolute value is bigger than a negative because they're all positive, or at least 0, right? But that's there. So what happens? What do I have to do first? Divide by -2. Isolate this thing. Just like if it was a radical. So I got to divide by -2. So what happens? Several things. Yeah, -4 divided by -2 is 2, and then this flips. Does anybody remember is that the restraining order, stay the hell away from me, or is that the stay close to me? Because what's the symbol? What's the inequality? Less than, right? Stay close. Don't go further than this. Stay less than that away from me. Stay close to me. Right? So anybody remember how you could rewrite this?
3 minus 2x equals 2, and 3 minus 2x equals -2.
Better way. That's less than 2, or it's greater than -2. You can write it in one fell swoop. You'd have to write it 2 separate, because that's the there and there. They're separate. But this one is a stay close to me sandwich, right? So bread, jelly in the middle. Yeah. I think I'm just hungry. I want dinner. And that's not too bad. It's all right. I know I didn't even show the work, but you subtract 3. So -5 less than -2x less than -1, and then you divide by -2. Shit. Which means 5/2. So you guys can handle this. Less than. That's going to switch. Greater than x. That's going to switch 1/2. And then you can write the interval notation, you can graph it. How's that? Is that good? Is that good? Good, because I'm not good at sandwich. Or something. Alright. See you guys Thursday. I'll have a test.